What is flux linkage in Faraday's law? Imagine a coil of wire sitting quietly in a magnetic field. Now, think about what happens when that magnetic field changes around the coil. The coil doesn't stay silent for long. It responds by generating an electric current. But what exactly is happening inside that coil? That's where flux linkage comes into play. Flux linkage is a way to measure how magnetic flux interacts with a coil that has multiple turns of wire. Magnetic flux itself is the total magnetic field passing through a surface, like the area inside a coil. It depends on how strong the magnetic field is, the size of the surface, and the angle between the magnetic field lines and the surface. When you wrap a wire around a core, each turn of the coil experiences this magnetic flux. Flux linkage takes this a step further. It is the product of the number of turns in the coil and the magnetic flux passing through each turn. So, if you have 10 turns of wire and each turn has a magnetic flux of 1 Weber, the flux linkage is 10 Weber turns. The formula for flux linkage is written as the number of turns multiplied by the magnetic flux, which is often shown as plus psi is equal to n plus phi. Here, plus psi is flux linkage, n is the number of turns, and plus phi is the magnetic flux through 1 turn. Now, how does this relate to Faraday's law? Faraday's law states that the electromotive force, or EMF, generated in a circuit is equal to the negative rate of change of magnetic flux through the circuit. When you have a coil with many turns, the law is modified to include flux linkage. The induced EMF is proportional to how quickly the flux linkage changes over time. The formula becomes plus V epsilon is equal to n plus frac plus delta plus phi plus delta t, where n is the number of turns. It can also be written as plus V epsilon is equal to plus frac plus delta plus psi plus delta t. This concept is essential in devices like transformers and inductors. Transformers transfer energy between circuits by changing the magnetic flux linkage between primary and secondary coils. Inductors store energy in their magnetic field, and flux linkage helps determine how much energy they can hold. In motors and generators, flux linkage influences the amount of induced EMF and the torque produced. In simple terms, flux linkage helps us understand how magnetic fields and coils work together to generate electricity. It tells us how the magnetic flux interacts with multiple turns of wire, affecting the voltage and current in electrical devices. Knowing about flux linkage helps engineers design better transformers, motors, and other electrical systems that relying on changing magnetic fields to operate efficiently.